Good morning or good afternoon because it's already 12. Dear friends, wishing you a happy Diwali today, the festival of lights, and also happy Kali Pujo because I'm a bong, so maybe I should have something to do in, say part of my Bengali culture. And also let this festival of light, which lights up our cities, minds, takes away all bad feelings from us. It is symbolized as kind of traditionally as a you know triumph over good over evil. But let mathematics also light up your mind. Let science also light up your mind and take you to a more enlightened future. Because I believe that in our country, a lot of young people are very curious about knowing things and they are very brilliant. They just don't get the best resources. They just don't get the best things. So if I want to paraphrase in हिंदी, हमारे देश में भी बहुत सी बच्चे हैं जिनको बहुत ही उत्सुकता है बहुत चीज़ों में, उनको जानने की काफ़ी ख्वाहिशें है, लेकिन फिर भी उनके पास उतना रिसोर्सेज नहीं होने के वजह से उनको मुश्किल हो जाता है जानने के लिए. I've been told many times to speak in Hindi in many in several cases, but my Hindi isn't very good. I'm sure you can make out. So I would be in kind of uh, speaking in English, and maybe uh, I was thinking maybe those who are my Bengali subscribers, maybe I can have a channel out in Bengali for some of the programs would be in Bengali, but just for the Bengali subscribers, if you want. Otherwise, I continue in English. I wish my Hindi was better and I could connect with many people, but I hope my subscribers will forgive me for that. Today, I want to tell you about four amazing books written by an amazing physicist. Leonard Susskind of Stanford is a very renowned physicist, living physicist. He, I think around 210 or 206 or 200, between 206 and 210, ran a series of lectures for people who are not specialized in physics like me, but have an interest in science, could be a scientist themselves, but wants to know, have the knowledge of basic physics, but at a deep level, not at a very superficial popular science level. But he published those lectures, which he called theoretical minimum, the minimum that you need to know to start doing physics. He had started publishing those lectures as books, but he published as Penguin, and penguins call them science. They, thanks God, they don't call them popular science. He tries in these books to do the math, explain the math, but actually doesn't shy off from using the real math. The math can be pretty involved. But those who know the math, for example, a math person like me can understand the subject matter pretty well. And everybody likes to have it's now become a cultural thing that okay, I should possibly have, if I'm a math guy even, it doesn't even, pure mathematicians sometimes say this, that they want to have knowledge about special and general theory of relativity or about quantum mechanics. To extend, now there are books called Quantum Mechanics for Mathematicians by Brian Hall, which is quite a very important book. So he wrote four books: Classical Mechanics, Quantum Mechanics, Special Theory and Special Relativity and Classical Field Theory, and the latest one on General Relativity. I have all these four books which I am going to discuss with you today, and just want to let you know that I have often told you that scientific books are not meant to be read from cover to cover. You don't read, usually don't read scientific books from cover to cover. You read the parts which you really need and focus on those parts. That happens with most of the books. But there are few books in life, even they are scientific, you will read them from cover to cover, right? So maybe it's a book on history, maybe it's a book story about someone's life, maybe it is a popular science book, but written by a very good scientist who actually tries to demystify or explain certain things in a simpler way, but not any simpler. And science can be made, as Einstein said, that made simple, but not any simpler. I mean, you cannot make things which is understood by everybody. When Richard Feynman was asked by journalist, in 5 minutes, can you explain what have you done for you deserving this Nobel Prize? He said, come on, listen, buddy, if I could explain to you in 5 minutes what I have done, then it wouldn't have been worth the Nobel Prize. So, those who have some interest in science, physics, and mathematics would actually enjoy these books of Leonard Susskind. The first one is Classical Mechanics, the theoretical minimum. Okay, so this is Leonard Susskind, the great physicist. He has also a huge contribution to string theory. So this book you can open up and see the math is fully there, and the math, and he explains to you very well, like he actually doesn't shy away from the math. The pages are full of math and also of deep physics. He uses the calculus of variation. He essentially teaches you analytic mechanics. He speaks about calculus of variation. He uses calculus of variation to do mechanics. He uses the principle of least action throughout. So among the few books I have read from cover to cover, this is a book I have read from cover to cover. And I say it's worthwhile because it teaches you how to reason in classical mechanics. How will you build the models? And it's very, very beautiful. What is the meaning of conservation law? What is the viewing system in motion as a dynamical system, modern dynamical system, the way we view dynamical systems in mathematics. So he does it in a very beautiful way when he starts. So he starts with this first chapter, what is classical physics? Now look at it. The nature of classical physics. And then if you look at the titles, so he has the nature of classical physics, then he has everywhere he has an interlude. He speaks about spaces, trigonometry, vectors, he speaks about motion, speaks about integral calculus, he speaks about dynamics, he speaks about partial differentiation, systems of more than one particle, energy, the principle of least action, symmetries and conservation laws, Hamiltonian mechanics and time translation and invariance, phase fluid and the Gibbs-Liouville theorem, points of bracket, angular momentum and symmetries, electric and magnetic forces, central forces and planetary orbits. This book is not only worth reading, this is worth rereading. I have read it once fully, end to end, but I always have a love for mechanics. Mechanics is one of those things which I enjoy. So this is a thing which is up again on my reading list. When I have a free time, when I travel, I'll have a small notebook with me. And though there is one small calculation error in double pendulum, the problem of finding the Lagrangian of the double pendulum and then finding the Euler-Lagrange equations, but still it's superbly and duperbly great book. Anybody who enjoys science and mathematics must have a copy of this book, and it isn't costly either. It's I think pretty cheap now in India. So maybe sometimes I feel that I should get 2 3 more copies and give it to people who are interested. This is really worthwhile. The second one, surprisingly, is not on relativity. The second one is surprisingly on quantum mechanics. He doesn't tell you stories about, oh, what Planck did and what he saw this black body radiation, Wien's law, and all kind of historical stories. He starts with quantum mechanics as a subject. What is the difference between quantum mechanics and what is the difference between classical mechanics? What is the meaning of a state in quantum mechanics when you're dealing with absolutely small elementary particles? What is the meaning of that? So those who want to know quantum information or quantum computing nowadays, they would do very well if they read this book first, because it is basically that information structure. It talks about kind of qubits, quantum bits, which has two values, plus one, minus one. So it starts with something called electron spin, and he wants to now measure this particular property of the electron, some intrinsic angular momentum, and he wants to measure it. So what difficulties one faces when one tries to measure such a small particle? What is the difference between observing the particle and the particle's actual state? So that kind of things are the starting key of this book, not the history. That you can find possibly very well written in Resnick's book on quantum physics. But this is some superbly, duperbly wonderful book. I'm using the word super duper basically. We used to use in IIT Kharagpur. There was a small cafe also of that name. It's still there. So this book, let me tell you what it starts with: systems and experiments. So you see, though, even your system is a quantum system, a very small system of elementary particles. Your measuring instruments are technically classical. You build them classically, and they're macroscopic instruments through which you are trying to locate it. Why is quantum mechanics different? And it tells you about these kind of measurement issues and how chance or probability becomes the most important tool in describing the state of an object, of such quantum objects or small objects in quantum mechanics, why you need it. So essentially, it says that when you can't see things with your open eyes, then you somehow have to open your other eye, the mathematical eye. And through that mathematical eye, you want to write down certain things, understand the results of experiments, and from them try to develop ideas and make certain conclusions and see whether experiments are telling you to be right. Quantum mechanics is confusing, weird, so it's very difficult to understand. It is again on my second reading list. This book, fantastic, fabulous, delicious. As I said, it's like whopping it up. I've read from page to page. Fabulous, fantastic. Mathematics means, if you think that this book is free of mathematics, please understand you are actually reading an actual physics book, or mathematical physics book. So please understand that these books are not, though it's published by Penguin, it's not popular science, it is science, right? So this is important to understand, that you really have to work out the technicalities. So he has written this book, and the quantum mechanics, as a second part of the installment. And in the every one the book, he tells what is the next book that is coming. Then came the marvelous, which and at this moment I'm reading it. Special relativity and classical field theory. Actually, when I went to UK to speak about the Maxwell's equation, I thought of taking this book and I forgot it. Then in Edinburgh, I bought that book from a store, Waterstone, on Princess Street, and went down to Maxwell statue and speak to make a video. But the video is still there, but I will get someone in the media technology cell here to edit for me, because I am not good in these kind of things. So the whole point was that the wind was so high, the sound was so high that all my words are lost in the wind. Maybe some are there, you can see. Maybe I'll do that video. It won't be a popular video, but those who want to see the statue of Maxwell, and that might inspire you, kind of thing. That's seeing that statue. So here is the book, Leon Special Relativity and Classical Field Theory. So you see, there is this. I also have its hardcover. Somebody gifted me the hardcover after I got the soft cover. So there is a little difference in the hardcover and the soft cover. So the hardcover, you see the extra writing, what you need to know to start doing physics, and otherwise everything looks the same, right? That line is not there because they don't have the space in the soft cover. So here he uses again the action principle, the least action principle to study relativity, very unlike many normal textbooks. He uses the least action principle and special relativity to understand electromagnetism, very unlike other books. He starts with Maxwell equations and ends with Coulomb's law, rather than the reverse direction in standard textbooks where you start with Coulomb's law and ends with Maxwell's equations. It's a very book rather. I do not know whether a traditional physicist would enjoy, but a mathematician would enjoy it thoroughly because it brings out the mathematical aspects. So here are certain diagrams from the special relativity part filled with equations. It is a highly mathematical book. Here you see the action integral. Action integral is the integral of the Lagrangian, where the Lagrangian is the difference between the kinetic and the potential energy. So these books are all worth reading. And now what I am reading, which I am going to read from cover to cover, I have got into something and I have just started reading it, is general relativity. So there is only a hardcover version now. Maybe I should also get the soft cover. In fact, for quantum mechanics, somebody also gifted me the hardcover. It's very funny. I buy the soft cover, somebody gives me the hardcover. And so for classical mechanics, nobody gifted me. So quantum I got, special relativity I got. So general relativity anyway, I got the hardcover myself. Maybe somebody will give me the soft cover, or maybe I'll just buy the soft cover to keep a kind of symmetry. So yeah, soft covers are very good to travel with when you feel like reading. So these books are like reading and rereading many times, and gradually the ideas seep into you. Gradually you feel uh, that you understand them much better than what you had earlier. So that happens pretty often. So here is also the book, the special relativity book. I have read up to page 26 actually. I am gradually working through it because you have to have some ideas of differential geometry here. So there is this tensor equations, this contravariant vectors and covariant vectors and all kinds of stuff. So you can see it's filled with tensor equation. But the page quality of pages have not been so nice. I don't know why. I don't know why the Indian print, even in the British print, I saw is the quality of pages. Maybe after COVID, things have gone a little bit off track for everything. So here it is. So, of course, you cannot escape mathematics. General relativity is obviously a highly mathematical subject. You need tensor calculus for this, and the tensor calculus here is very beautifully explained. So these are this Leonard Susskind books which I have read cover to cover. So hence, with this small, or rather, oh my God, 19 minutes I have spoken. My God. So I wouldn't waste much of your time, and you don't even need to see a video on this fun day, this enjoyable day of Diwali. So when you find time, have a look at these books. If not you, your library, or you can ask your parents for gifts, those who are so much interested. So, and get them and enjoy and read them and reconnect with me about these books, and what do you think these books are. And if somebody has some questions from these books, except the general relativity part, which I am reading now. I would be very very happy to answer. Thank you so much. Have a great day. आप सब एक अच्छे दिन बिताइए, यही हमारा कामना रहेगी। और ये किताब देखिए और इसको पढ़ के थोड़ा एंजॉय करिए और मैथ्स का जो ब्यूटी है उसको फील करिए। What a poor Hindi I have. Anyway, thank you very much. Have fun and enjoy yourself.